Today we are going to discuss third chapter of real analysis, series of real numbers. New chapter, series of real numbers. Series of real numbers. What is meant by series? Okay, series. Series means infinite series which is a contains real number such that suppose that here if we taking any of the series, okay, series their summation series can be written in the form of in the summation of an. Okay, so series, suppose that an equal to taking 1 upon 2 raised to n, suppose that. Okay, so their elements are of the form of, if a1 is equal to, n, if we putting n equal to 1, then the value of 1 upon 2 raised to n is 1 by 2. Then number a2 is the number a2 is 1 upon 2 square. In this way their elements, but the summation of an equal to, here an equal to 1 upon 2 raised to n, then series an equal to summation of all these terms. Okay, that is 1 upon 2 plus 1 upon 2 square plus 1 upon 2 cube plus up to so on. This is called a series. Suppose another example, if we taking an equal to series an equal to, if we taking minus 1 raised to n. Okay, minus 1 raised to n, this an is a nth term of nth term of given series. But series in can be written as series means the nth partial sum of the series. Okay, so here suppose we taking an is equal to minus 1 raised to n, then a1 is equal to minus 1, then a2 is equal to their term is equal to 1. Okay, in this way value are minus plus minus 1 we obtain. But series an is equal to, if we taking partial sum, that is minus 1 plus 1 minus 1 plus 1, in this way minus 1 raised to n, in this way take a values. Okay, so these values are taking a series. Okay, so that is definition of series. Definition of series means a sequence an which contains, sequence an means these all terms this minus 1 then minus 1 a3 is equal to, then these are the elements of sequence. Okay, so this sequence an of real numbers, and partial sum suppose denote the sn or any whatever may be notation. Okay, so here we denote sn. Okay, sn is equal to summation of nth partial sum a1 plus a2 plus a3 plus up to so on an, that is, this is called as nth partial sum of series. This is called. Okay, so this is a sequence an, that is these values are taking this sequence minus 1 plus 1 or these 1 by 2 1 upon 2 square, these are the sequence, and sn is the sum of the partial sum of this element. That is, here if you taking s1 is equal to a1, then s2 is equal to a1 plus a2. Okay, then s3 is equal to a1 plus a2 plus a3. In this way we obtain the nth partial sum of series. Okay, nth partial of the series, this is called the nth partial sum of the series. Okay, so another example, if we taking an equal to if we taking 1 upon n, then a1 equal to 1, a2 equal to 1 by 2, then a3 is equal to 1 by 3. In this way elements are obtained. Okay, so this is a sequence, and nth partial sum of Sn. Sn is the first element is a1 means 1, then here s1 is equal to 1, then s2 is equal to 1 plus 1 by 2, okay, 1 plus 1 by 2, so their value is 3 by 2, then s3 is equal to 1 plus 1 by 2 plus 1 by 3. In this way, this is called a nth partial sum of the series. Okay, so definition of series is definition of series. Series of real numbers. Series of real numbers. The infinite series. Definition of this series. The infinite series. The infinite series. Series can be written as summation form. Summation of where n runs from 1 to infinity. An is an order pair, sequence an and sequence sn. Okay, order pair sequence sn where sequence an is a sequence of real numbers, and sn is here not sequence. Okay, here only sn is equal to partial sum of nth partial sum, that is first n terms and their sum. Okay, that is nth partial sum a1 plus a2 plus a3 plus up to so on an, where n belongs to index set I. Okay, the number an is called nth term of the series. The number an is called nth term of the series, and sn is called as nth partial sum. Okay, sn is called as nth partial sum of the series, Okay, so this is our definition of this is the an means the nth term of the given series. An is the nth term of the given series, and where sn is the nth partial sum of the series. So their convergence. Next point is convergence and divergence of series. When given series is convergent, suppose that this series is given there, and when this series is convergent, if sequence sn, if this sn is a a1 plus a2 plus nth partial sum up to an. Okay, so this is the partial sum, and when this sequence sn is convergent, if this sequence sn is convergent, then series an also convergent. Okay, so and if this sequence sn, that is n partial sum of the series is divergent, suppose which is divergent, then series will be divergent. Okay, so if this sequence is convergent, that is n partial sum of given series is convergent, then we see that given series is convergent, and the n partial sum of the given series is divergent, then we see that given series is divergent. Okay, so next point is convergence and divergence of series. Okay, so let here summation of an, where n runs from 1 to infinity, an be the with a series of real number, with a series of real number with with partial sum, with partial sum Sn is equal to, partial sum is a1 plus a2 plus up to so on an, okay, plus up to so on an. In this way, given that if this sequence Sn is convergent, this sequence Sn is convergent and converges to L, converges to any, converges to, suppose that A, say that, okay, A, take any limit, then series An is also convergent, series An is also convergent, where n runs from 1 to infinity, and series is also converges to A, okay, is also converges to A. And if this sequence Sn is divergent, this sequence Sn is divergent, that is there is no limit exist, okay, there is no limit exist, then we say that series is also divergent, okay, series An is also divergent, is also divergent, okay. In this way we have to convergent and divergent. Note here, next is note, okay. So here if limit n tends to infinity, Sn, that is limit of Sn is exist, that is limit of Sn is exist and which is finite, okay, their limit is exist and which is finite and is equal to, suppose that A, okay, say, then we say that series An, okay, where n runs from 1 to infinity, An converges to A, okay. Here when series is convergent, if the limit of given partial sum is exist, okay, that is limit n tends to infinity, Sn is exist and which is finite, whatever may be their limit, whatever may be exist, okay, which is finite, then we say that series An is also convergent and converges to that point, okay, converges to limit A, okay. So this is one note. Then second, if limit n tends to infinity, Sn is a n partial sum of series, okay, and their limit is exist, okay. So if their limit is exist and finite, okay, limit exist and finite, but which is not unique, okay. So their limit is exist and which is finite and but which is not unique, then sequence An, then series An is a oscillating series, then we say that given series is a oscillating series, that is their limit exists, that is sum of partial sum, limit of sum of partial sum Sn is a exist but which is not unique, that is there has a different limit exist, okay. Then we say that given series is a oscillating series, here for example minus 1 raised to n into An, suppose that, okay. For this example minus 1 raised to n, also this one example, this second example is also minus 1 raised to n, okay. Series n runs from 1 to infinity, minus 1 raised to n, this is also oscillating series, okay. Why this is oscillating series? Because here An is equal to given that minus 1 raised to n, okay, and their sum is Sn is a n partial sum of given series, so their elements are, first if we taking n is equal to 1, If we taking n is equal to 1, then minus 1. If we taking n is equal to 2, then their value is plus 1. 1 plus 1 minus 1 plus 1 plus 1 minus 1. In this way up to so on minus 1 raised to n. Okay, so this is a sum of nth partial sum of nth partial sum of series. This is a nth partial sum of series, and if we taking, suppose s1 is equal to s1, if we taking n is equal to 1, then minus 1, then s2 is a minus 1 plus 1 equal to 0. Okay, then suppose s3 is a minus 1 plus 1, again minus 1. Okay, that is sum of three terms. Their value is again minus 1 plus 1 0, remaining minus 1. Okay, then s4 is a sum of fourth term, sum of fourth partial sum of the series, fourth term of first fourth term, that is minus 1 plus 1 minus 1 and plus 1. Okay, n is equal to 1, then n is equal to 2, put KLN after putting n is equal to 2, then their power is positive after 4. Okay, so in this way minus 1 plus 1, so their value is again 0, and continue in this way. Then sequence Sn is a contains elements. First element is minus 1, then second 0, then third minus 1, then 0, then minus 1 up to so on. In this way this sequence is exist. Okay, in this way this sequence is exist, and but their limit is they given sequence has two limits, minus 1 and 0. Okay, so both are different limit, and therefore given sequence has limit, therefore given sequence has limit is not unique. Okay, so therefore limit of Sn where n runs from n to infinity is not unique, and in this sequence has also, suppose s1 is equal to minus 1 minus an, here 0, then minus an, in this way. Okay, and then their values are also minus 1 an in this way. Okay, so given sequence has limit is not unique, and therefore given series minus 1 raised to n is a oscillating series. Okay, this is one of the example where n runs from 1 to infinity. Then next example, suppose that check the convergence. So before that one point is remaining. Notation of series. Notation can be written as x is equal to xn or an. Okay, suppose that an or series an where n runs from 1 to infinity. This is one also notation of given series. Then another notation here x is equal to xn where n runs from 1 to infinity. In this way one of the notation of for given series. Okay, so in this chapter I will using this notation. Okay, so here x is equal to summation of n runs from 1 to infinity an, that is series an. Okay, so next example here, check the convergence. Check the convergence of the series. Series is given that 1 plus 1 by 2 plus 1 upon 2 square plus 1 upon 2 cube plus up to so on, in this way. Okay, so series is given that. Okay, this series is a sum of the 1 plus 1 upon 2 plus up to so on, in this way given that. So their convergence, how to find the given sequence given series convergent or divergent. Okay, so here let given that here what are given? Series is 1 plus 1 upon 2 plus 1 upon 2 square plus 1 upon 2 cube plus up to so on, which imply that an is, what is an given? That summation of n runs from 1 to infinity is equal to what here given? What is here given? 1 plus 1 by 2 plus 1 upon 2 square plus up to so on is given, which imply that an is must be an is equal to 1 upon 2 raised to n. That is if we taking summation of an is equal to 1 upon 2 raised to n, where n runs from 0 to infinity. Okay, so 1 upon 2 raised to n. Okay, in this an, if we taking 0, n equal to 0, then 1 upon 2 raised to 0 is equal to 1. Then if we taking n equal to 1, then this is a summation, that is this sign is a summation, that is adding term by term. Okay, so n is equal to 0, then we get 1. Okay, if we taking again n equal to 2, then 1 upon 2. If we taking 1 upon 3, n equal to 2, n equal to 2, then 1 upon 2 square and up to so on, we get this sequence. Okay, therefore an is equal to, given that 1 upon 2 raised to n, an is equal to 1 upon 2 raised to n, sequence an is equal to 2 raised to n, and therefore sequence of partial sum, what is here given? Sequence of partial sum equal to Sn is equal to 1 plus 1 upon 2 plus 1 upon 2 square plus up to so on, lastly nth term, what is power here? This is first term, then power of 2 is 0. This is second term, power of 2 is 1. So here this is third term of series, so their power is 2. Okay, third term power 2, that is minus 1. So lastly after nth term power of 2 is must be n minus 1, and so therefore their sum is, what is their sum is? Their sum is 1 upon 2 raised to n divided by 1 minus 1 by 2 by using what result here use? Here result sum of 1 plus 2 plus up to so on n. Okay, so using this, the result is n into n minus 1 divided by sum of their addition is n into n minus 1 upon 2. Okay, so using this result, here result use the a plus 1. So this is our standard result. Okay, so their sum is must be adding one power divided by first term into difference between these two. Okay, so their sum is can be written as 1 plus 1 by 2 plus 1 upon 2 square plus up to so on 1 upon 2 raised to n minus 1, which is equal to so if we taking difference between two terms divided by difference between two terms. Okay, so using this 1 minus 1 upon 2 raised to n divided by 1 minus 1 by 2. Okay, and so solve this. If we taking denominator same, then 1 minus 1 upon 2 raised to n divided by 2 minus 1 divided by 2. Okay, so which imply that 2 we get a upper side, which imply that 2 into remaining only 2 minus 1 1, so remaining only 1 upon 1 minus 1 upon 2 raised to n in this way. Okay, and so we have to find the limit n tends to infinity, Sn is equal to limit n tends to infinity 2 into 1 upon 2 raised to n, 2 into 1 upon 2 raised to n. If we taking n is equal to, which imply that if we taking n is equal to infinity, then n is equal to infinity, 1 upon 2 raised to infinity 0. So remaining only limit n tends to infinity 1 minus 1 upon 2 raised to n. So which is equal to 2 into limit n tends to infinity 1 minus limit n tends to infinity 1 upon 2 raised to n is equal to 2. Their limit is 1 minus their limit is a 1 upon infinity 0. So their limit is a 2, and therefore their limit is unique. Here their limit is sequence of limit is unique, and therefore this sequence Sn is convergent and converges to 2, and therefore sequence is convergent. Therefore series An, where n runs from 0 to infinity, is series 1 upon 2 raised to n is also convergent. Okay, is also convergent and converges to 2. Okay, converges to 2. In this way we check that the sequence are convergent or divergent. Okay, so another sequence is given that here suppose that next sequence, example, series n runs from 1 to infinity, an is equal to 1 plus 2 plus 3 plus up to so on. This series is given that. So solution, how to check, how to show that given sequence is convergent or divergent. Okay, so here given that series 1 plus 2 plus 3 up to so on. Let series n runs from 1 to infinity, an equal to series, here this series is a n. Okay, if we taking n is equal to 1, then 1 plus 2 up to so on, in this way. That is sum of the this summation of n. Okay, so sequence of partial sum is partial sum Sn is equal to, Sn is a sum of the first nth term, 1 plus 2 plus 3 plus up to so on, last term is n. Okay, so their addition must be n into n plus 1 divided by 2. Okay, so their sum is a first nth term, their addition is a n into n plus 1 divided by 2. Okay, so in this way find limit. Okay, limit n tends to infinity, Sn is equal to limit n tends to infinity n into n plus 1 divided by 2, and if we taking n is equal to infinity, then their value is infinity. That is given sequence Sn has limit is infinity, that is which is divergent. Okay, that is which is divergent, and therefore series An is equal to series n runs from 1 to infinity is divergent series. Okay, in this way we have to find the given series is convergent or divergent. Okay.